And I think the stuff, when I distribute the I, it becomes this. Is that a negative 40I? Is that a plus 20? And then plus a 2IB. So if you guys don't mind, I'm going to take these two constants above my squiggly lines, and I'm going to sail them to the right-hand side of the equal sign. But that gives you positive 20 on the right.
Did you say sail?
Yes. Send them over. And if I take, oh look, two other constant terms. They're just not real. And send them to the other side, wouldn't that give me a positive 69? Now on the left-hand side, I got a couple b terms left over, and one of the b terms has a coefficient negative 4. The other has as a coefficient positive 2i. Ah, but that means I can solve for b. I think it's simply this fraction.
What is that symbol next to the 10?
Plus sign.
Oh, okay.
Perpendicular.
So I kind of thought it was, but yeah.
What's next?
Fraction.
Yeah, I think I
Yeah,
gotta rewrite
probably.
that complex. Well, excuse me, the ratio is two complex numbers as the same complex number. Then I'm basically done, right?
Oh, no, you got
Nowhere near done. I gotta go back and recognize that the original DE, that was non-complex value, had a sign factor in there. Which means I better put all the stuff back in, find Z sub P, blow it all up and grab the imaginary component. Because the original force is a function of all the sine of x. Did you guys see it?
Yeah.
Did you want me to finish it?
No, it's fine.
Brad, you asked.
Yeah.
Is that sufficient?
Yeah.
Chris?
When we started doing first order linear differential equations, we had a lot of, maybe not a lot, but we had a sufficient amount of real world applications. Are you going to do that again soon with these linear differential equations?
Aren't we getting into
I think it would
circuits?
be interesting just to see the applicability of this.
See, guys, I know I'm not done. But because I took today and included homework, tomorrow, can I just completely take over? And maybe I'll come in and I'll give you a presentation on mechanical systems and electronics.
Okay, that's 6.5 and 6.6, right?
Yes.
Yes.
Statement.
Yes. The only reason I skipped this is because we were coming up to the weekend. Last week's lunch just ended. And I wanted to send you guys home with a couple techniques, not just the method of determining coefficients. I really wanted to plug in there my variation preference technique. And I'll be honest with you guys, I'm not prepared for class today. I didn't realize I had more work with variation parameters because apparently I only gave you a second order DE.
We didn't do third orders yet.
And I just remembered that I was looking at the homework. So I completely forgot about that. So
Oh.
today, before we leave, I really want to make sure I give you an example of the third order DE.
Can I just ask a quick question? So the next test that we have, are we gonna? I think it was like 7.6 is the one that you said is when we start getting into the really long problems. Is that going to be on our next exam? Are we going to Are we going to cover that? And if so, when's that lecture going to be?
Okay, hold that thought. Because our next exam is next Thursday.
Yeah, next Thursday,
We have no class before.
and no class Monday. So I'm just terrified that I'm going to come in on Tuesday. We're going to do that lecture, and then I'm going to have to like wrap my head around that in like 2 days.
So let's do this. Let's just count. Tomorrow? 6-8. 6-5 and 6-6 all tomorrow.
Okay.
I know it sounds excruciating. 6-5 and 6-6, they're not new techniques. It's just using the same old method of undetermined coefficients. It's just, I'm just going to put an application skill in.
Okay.
So it's nothing serious mathematically. That's tomorrow. That's Tuesday. Wednesday, 7-1 and 7-2. 7-1 and 7-2. Thursday, 7. Monday, 7-4.
No Monday.
All right.
Tuesday 7.4.
Tuesday, 7-4.
Is that gonna be it?
Man,
We can't do Wednesday, right? Because
that
would
means
be
it's another easy exam.
easy.
Gosh.
Oh, it's all easy, right? So, I mean, there's no,
Is this the third exam or fourth?
this is the last exam that we have before the final.
That's crazy.
But all the exams are easy, right? So it'll just be, you know, one of the normal exams. And the long problem, I mean, even if we did have it on our next exam, we couldn't possibly do that in class, right? Oh, no. I mean, if it takes 2 hours to do, we don't even have 2 hours.
Oh, it doesn't take 2 hours, just like 20 minutes. Well, it'll take me 40 or 50 minutes because I'm talking and explaining the steps. But you wouldn't take that long.
Of course I wouldn't.
No.
Is solving a third order differential equation using a variation of parameters analogous to the second order one, or is it substantially different?
Quite analogous. Not substantially different at all.
So did you say we're covering 6.9 or are we not going over that?
Is that
Reduction.
reduction order? Do you guys mind if I don't cover this section? Can I tell you what it is real quick in 60 seconds? It's a technique I've already used in class. Remember how I derived, maybe you don't, but remember how I derived, when it comes to a higher order constant coefficient homogeneous DE, do you remember when I said if we have duplication of a solution, if I get just one real solution from the characteristic equation, my solutions are going to be the form C1 plus C2x all times e to the Rx. The fact that the way I got that x in there is I used reduction of order technique. But the reduction of order technique only works if you've already got one solution. And so I want you guys to learn how to solve DEs, period, where you're not just going to be given a solution, someone's going to say, hey, look for another one. That's the beauty behind reduction of order. And to be honest with you, I always cover it in other versions of the book because it came before the other techniques. And I need it for the other techniques. And for some reason, you put it at the end of the chapter, when in reality, I've already used it. So we're done with it. And I'm not going to have you guys use it. It's just kind of silly. I want you to come up with solutions on your own. Makes sense? That's why it's not that formidable. You guys, I don't have an example. Can I be so rude? Let's just open the book and grab an even number. Is that okay? All right. I mean, obviously I had examples when I came to class that day, but
Don't they have the solutions for all the evens in there too?
I don't know. Do your solutions? You
The
guys have all
solutions
the
manual that I have has them, but I don't really look in the back.
Yes.
Oh, the back only has
Gotcha. Gotcha.
It makes more sense when you,
Makes what?
it makes a lot more sense when you go through it.
Does he do things that different?
It's like they don't skip a lot of
Sometimes.
steps.
The solutions may not working very well.
Yeah.
yeah. Sometimes they'll skip steps or they'll do it like using greens. So,
Yeah.
but I like greens.
One day I have to sit down and just look at it, but I just haven't.
Yeah.
So you guys, I'm going to cheat. I'm going to dive into section 6.7 in the exercise set. And I'm going to grab one. But I want to grab a fun one. Because I got time. I got 24 minutes. Ooh, I like, 21's odd. Shoot. Let me grab 20. That looks good. So you guys give me time for just one example. Tomorrow when we come in, can I just completely talk?
Yeah.
So I have for number 20 this differential equation. Now I maintain, given that, I've got a factor of x to the negative 2 power in the forcing function's position. For free, I cannot use my method of undetermined coefficients, or for that matter, using annihilator's technique. So I think I have no choice. I have to use variation parameters technique for that reason. Can't use variation parameters technique until I come up with my two, or in this case, excuse me, 3 linearly independent solutions to my characteristic equation. So let's take a peek at that characteristic equation. In the homogeneous case, I think I've got an r cubed minus 3r squared plus 3r minus 1. Oh, thank goodness, something interesting. Darn, I That's just too easy, isn't it?
Yeah.
Jesus. So disappointing. So I think y sub c of x, my complex solution is going to be C1.
Plus C2x plus C3x.
Very nice. Does everybody agree? Mike?
I'm curious, why was it so easy to factorize as r minus 1 cubed? Is it?
Pascal's triangle.
Okay.
I immediately recognize that r minus 1 to the third power. And I maintain, in the non-homogeneous case, I'm going to have my y sub p be equal to, guys, let's do I say this in English. So I'll write it differently. I think it's going to be u1 times y1 plus u2 times y2 plus u3 times y3. Now that may be what my trial particular solution looks like. But I think it's going to have to satisfy a whole system of equations. And the system of equations it's going to satisfy is following. It's going to be my u1 prime times y1 plus u2 prime times y2 plus my u3 prime times my y3. However, it is going to be the case that I've got another equation. Oh, by the way, it's not an equation, is it? Sorry. But by the way, I've got another equation in which I've got u1 prime times y1 prime plus u2 prime times y2 prime. Plus u3 prime times y3 prime. Oh, by the way, that's going to be equal to 0 as well. And I think my third equation is going to be my u1 still a prime times my y1 double prime plus my u2 prime times my y2 double prime. Egads, what does that give me? Plus my u3 prime times my y sub 3 double prime. Oy, yo, you guys, what is that going to give me? Okay, now I'm too tired. How about the first? Times through the second. Plus the second, bless you, times through the first. That's what's going to be equal to my forcing function. I can't remember it. Somebody? The forcing function?
2 times x and negative 2 times e to the x.
Got it. That's the system I'm going to solve. I suppose I should simplify a tad bit. Does that become a 2 plus 4x plus x squared? I don't know, you guys, you tell me how you want to solve the system. I'm being honest.
Matrix.
Yeah, you probably are going to use a matrix. Do you want me to use an augmented matrix? You want me to use Kramer's law? I'll do whatever we like. Kramer's law. And if I use Kramer's law, I think my D is going to be this. Okay, hold it.
Kramer's rule is unwieldy for
I think Kramer's rule is cumbersome for bigger systems. For 3x3s, I don't know if it's that bad. But it's up, that's why I'm saying it's up to you. I'll solve which way you want. And I think my D becomes this. Sorry I'm so slow, you guys. Oh, did I forget my exponential factor? Sorry. there's something very wrong with this one, isn't it? Thank you. If I'm gonna pull out an e to the x for each and every component, it's like pulling out
Why don't you
three
just-
columns, not three of them. And in evaluating, I guess that gives me e to the 3x times, oh, let's dump this out big 3 by 3. Let's convert it to 2 by 2s. Let's list a cofactor expansion. I
Is
think
there
that-
any reason why you kept the e to the x in there? Like, why didn't you just divide out the e to the x?
That's fine, you're right. I can't argue with you. You know, maybe my life would have been easier because in the end, I'm gonna divide d sub x by b. And d sub x is also gonna have e to 3x. It divided by itself is common. I agree.
Okay.
I've already put it in, so let me just expand this out real quick.
Okay.
Because I don't think I will. I think I'm running out of room. I was gonna try to save myself space down here, but I don't think it's gonna work. So give me this. Minus this. And then finally plus this. And that's gonna give me the following. Got my darn lingering e to the 3x times, well, let's multiply out. Instead of 1 plus x times 2 plus 4x plus x squared. Minus my 2 plus x times 2x plus x squared. Minus my x times 2 plus 4x plus x squared. Instead of plus x times this. And then finally, plus my x squared times some stuff. I don't know what the stuff is. Is that a 2 plus x? And then a 1 plus x. What do you think?
It is. I think we should just pull up, rule from Outlook.
Did you guys see where I'm going with this?
Yeah.
Yes, fine.
So would the matrix, or using a matrix be just as bad, or?
I think it'd be easier. No, it'd be bad, because you have to do a polynomial log division or multiplication, and you just get, it's just a mess no matter what you do.
The book does have a paragraph that just says, since we have more than 2 variables, it's more efficient to use Gaussian elimination rather than Craig's rule.
Yeah, in my head I was trying to do just a couple steps. And I see it's going to be a lot less work, only because if you look at the first column, they're all ones. And so I get to force zeros down the first column except for the main diagonal. And that means I only have just one more item to force to be 0. And using Gauss-Jordan elimination, I would not do this. You talk about polynomial division. I wouldn't have forced these to be 1s. I would leave it with whatever they are. To force these two to be 0s is really fast with Gauss-Jordan elimination. And there's just a little bit of word forcing this one right here to be 0. So I do think, now that I've got everything written out, it really would have been much easier using Gauss-Jordan elimination on and off in a matrix. But that's why I asked you guys. I'll do it whichever way you like. So what's going to be next?
Are we continuing with the Cramer's rule?
Yeah, what's Cramer's rule is next? You give up.
Well,
Because
no,
you
honestly,
give up
it's-
because I have to do this 3 more times.
Yeah.
Oh, yeah. Yeah.
But if we were to continue it, you would just throw in the 0, 0, and the 2x
I agree.
into the, each row and repeat the process over again.
But at least those would be easier determinants to evaluate, because I get zeros in 2 of the bases in the first column. So the cofactor expansion just won't turn. Same thing with the remaining 2 after that determinants, d sub s and d sub z. So nothing bad. But you guys get the idea. You can take it from here. And that's all I want to suggest. Well, let's take a peek at what we can handle in.
Do we ever get like to a point in math, like even in like upper level math, where they actually let you use graphing calculators to solve this kind of stuff, or do you always just have to kind of resort to just tedious
Oh my
Gaussian
goodness.
elimination?
In higher level mathematics, we would never deal with these things.
You never deal with them?
Well, with my sub-disciplines of mathematics. What's that?
How would you solve this without advanced computation?
This would never come up in advanced mathematics. Because I think with the fields of real analysis, complex analysis, abstract algebra, we're not getting our hands dirty. We're just proving theorems. So higher level mathematics is very, very different. Very different. So in section,
So are you saying that we're getting to the end of this tediousness, or? Because I mean, like, I don't really think that Gaussian elimination is hard or anything like that. I just think it's really long and tedious.
for those of you going into physics
Yeah.
or mathematics, I have to confess, you're going to take another course like this called partial derivatives. Excuse me, partial order differential equations.
Okay.
Now, that's going to be very computational like this. Some of you might take something called numerical analysis. That's heavily computational.
What about an advanced linear algebra course?
There as well. Most of the fields are not feeling this at all, in mathematics.
Okay.
Oops, I'll get the right chapter. How about in section 6.7, can I now officially assign exercises 19? Holy cow,
I think there's a lot.
there's hardly anything in here. Oy, oy, oy. How about 19 through 22 all? Can I add to this? Page 531. I am dumbfounded. Not one example, not one exercise in the review set, in the chapter review, not one, requires variation of parameters on a fourth order or third order DE.
Thank God.
Why'd you say that? All right, I guess that's it, Chambers.
You have an example somewhere you could put up on the website?
Yeah, if
I'll
you want
do
to
that.
post some
I'll
for
do
us or
that. I'll post a
something
few more.
for practice.
All right.
Need to do